Ooh, that's pretty popular stuff. So linear functions, ax plus b, that's when you have a slope-intercept form. Quadratic, that is what you worked with yesterday. Those were quadratic functions. That's when you have an x squared in there. So that's x equals ax squared plus bx plus c. The graph of that is called a parabola. That's all you were doing yesterday, other than the vertical lines that you're throwing in there. You were doing parabolas. Parabolas can both go up or both go down. And then absolute value, which is what we did Tuesday. So a lot of this lesson is going to be comparing a basic function, a basic type of function, to some sort of translation, rotation, or reflection, or dilation. Okay, so they're going to give you a function, and they're going to ask you, how is this different from the basic function? And we're going to graph them. Okay. So to write down those, so on the constant, what do you think would be the most basic number for this to equal? F of x equals what constant graph would be the simplest? Yeah. 0. And we'll write down these parent functions, because they're the ones that are going to be what we need to start with. Auto notes finishing up today, and then if we have some time, we'll do a little bit of practice, but we'll practice tomorrow and get to work on the assignment. Okay. Caitlin, do you have it all down? Okay, we good? Okay, wait on me. So, your parent functions. Parent functions are the most basic and simplest. And basic and most simplest graph of the 4 types of functions. So if you have a constant, your simplest one is y equals 0. If you have a linear function, your basic one is y equals x, or you can think of it as y equals 1x plus 0. You don't have to write down this last thing yet. That was the example. So quadratic is just y equals x squared. Absolute value is y equals absolute value of x. So those are what they consider the parent functions. Every other function is some variation of what's happening here. So when you start putting other numbers in there, that's when you start translating it, or reflecting it, or dilating it. So we should be able to graph the absolute value. I'll show you on your calculator where that button is. If we don't have time today, I'll do it tomorrow. You're probably going to have to wait till next Thursday. There will be another quiz. Into the 9 weeks is next Thursday. So hopefully we can get this done tomorrow, and then next Monday and Tuesday get the last lesson done. we can finish up chapter 2. Hey, we made it through one chapter. Okay, a lot of stuff in this one. Good one to start off with. Okay, so what your questions will start off with. You'll just have a few of the simple ones. It says identify the type of function represented by each graph. This is page 113. So this is just stating, is this a constant, a linear, a quadratic, or an absolute value? So all you have to do is say, hey, this is a, in this case, what is it? The linear function. You don't have to write out what the equation is or anything like that. You can say, hey, this is a linear function. Okay. Number 2 is then what? Oh, a parabola? It kind of looks like it, but do you see how these are straight? Okay, a parabola is going to curve up a little bit. No. That's a good one. So the parabola is going to be like a bowl. Think of parabola like a bowl. And absolute values of these. And don't put the parabola as the name of the graph. Put the name of the function. So you want to write quadratic instead of parabola. Okay. Okay. That's the easy part. So when we get to these, it's going to say describe the translation in each function, then graph the function. I'm going to want you to graph the parent function and the original function. And we will use our calculators to help us if we need to. Okay, especially with some of these quadratics. Okay, but we will be graphing both of these on the coordinate plane. So the first thing, on number 3, what is my parent function? Which one of the 4 is going to be my parent function? Is this a constant? Is this a linear? Is this a quadratic? Or is this an absolute value? Okay, so you see the x squared? That's your clue that it's an x squared. You have a quadratic. Okay. So for number 3, okay, I'm going to say, okay, I have a quadratic. Is this minus 4? Does the minus 4, is that inside or outside? Don't answer yet. Let everyone think about it. I want you to try to think about what is it inside or outside of the function. How many say inside? Good response. Okay, that is outside. If it is inside, it would be x minus 4 in parentheses and then the squares on the outside. Okay? So it would be x minus 4 the squared. So since it's on the outside, that fits. Now this is where this comes in handy. This situation, right? So it's minus 4 on the outside, so we say it translates the graph k. Instead of k, what was the value of k in this? 4 units down. So we're going to say it's a quadratic. It translates y equals x squared. There's my parent function. 4 units down. That is describing the type of translation that you have. Move that down so we still see. So this describe the translation. I recognize my parent function. The parent function was y equals x squared, so it's going to translate my parent function 4 units down. And now we get to graphing. Calculators make that handy. Okay. So wrap this up real quick, and then we'll do some more tomorrow. So on your y equals, yeah. But yes, I do have some more when you need. So y equals x squared and y equals x squared minus 4. So that's, you have to go to y equals up in the top left. Make sure all your plots are off. you have anything highlighted up above there? Let's turn those off. Go up, then press enter, then go back down. Okay, press enter. You can do it here also. Go up. Highlight, press enter. The X is right next to the alpha button. That's your variable.
Did you say alphabet?
Alpha button. Alpha button. Okay. You all have it graphed? If you hit graph, it should look like this. Now, if your window looks different, go zoom 6. Go zoom standard. Your window may look different because we're doing stat plot stuff. Then go zoom, and then option 6, which is zoom standard. Okay. You should get 2 lines, a parent function and your translated function.
It looks like a nose.
Zoom 6. Okay. So from here, how do we get these points? Where do we go to get the points of these two? The table. So second graph takes you to your table. And now you have the points that will help you graph your problem. Notice you have 2 y values, only 1 column for x's. So y1, if you forget which one is which, on your graph, if you hit trace, it'll tell you in the top left corner what graph you're on. Okay? Okay, so we'll do some more practice with this tomorrow. No, it's not. It'll be due Monday.